Hi, I'm a tutor in Uplatz. Today we are going to discuss about secrets of Printf in C programming language. Printf in C language function do formatted printing. The same function is also available in PER. This paper explains how Printf works and how to design the proper formatting specification for any occasion. Background: in the early days, computer programmers would write their own subroutines to read in and print out numbers. It is not terribly difficult actually. Just allocate a character array to hold the rest, divide the number by 10, keep the remainder, add x30 to it, store it at the end of the array, repeat the process until all the digits are found, then print it. Too easy, right? But even though it was easy for Einstein, it is still took some effort. And what about error checking and negative numbers? So the computer programmers brought forth libraries of pre-recorded functions, and it was good. Eventually, the most popular of these functions were canonized into membership in the standard libraries. Number printing was popular enough to gain this hallowed honor. This meant that programmers did not have to reinvent the number of printing subroutine again and again. It also meant that everybody's favorite options tried to make it into the standard. Thus was Printf born. In the most simple case, Printf takes one argument, a string of characters to be printed. This string is composed of characters, each of which is printed exactly as it appears. So Printf XYZ would simply mean print an X, then a Y, and finally a Z. It is not exactly formatted printing, but it is still the basis of what Printf does. Naturally, special characters. To identify the start of the string, we put a double quote at the front. To identify the end of the string, we put another double quote at the end. But what if we want to actually print a double quote? We can't exactly put a double quote in the middle of the string because it would be mistaken for the end of the string marker. Double quote is a special character. Then print what you see. Rules do not apply. Different languages take different approaches to this problem. Some require the special character to be entered twice. C uses backslash with U as an escape character to change the meaning of the next character after it. Thus, to print a double quote, you type in backslash double quote. To print a backslash, you must escape it by typing another backslash in front of it. The first backslash means give the next character its alternate meaning. The second backslash has an alternate meaning of double quote print a backslash. Without a backslash, special characters have a natural meaning. With a backslash, they print as they appear. Here is a partial list: backslash, escape the next character, backslash, backslash, print a backslash, double quote, start or end of a string, slash, backslash, double quote, print a double quote, single quote, start or end of a constant, backslash, single quote, print a single quote, percentage, start a format specification, backslash percentage, print a percent sign. Alternative special characters, on the other end, we have characters that normally print as you would expect, but when you add a backslash, then they become special. An example is the new line character. The print an n, we simply type in an n. To print a new line, we type in a backslash n, thus invoking the alternate meaning of n, which is new line. Here is a partial list. Backslash A, audible alert bell, backslash B, backspace, backslash F, form speed, backslash N, new line, line speed, backslash R, carriage return, backslash T, tab, backslash V, vertical tab. Format specification: the real power of Printf is when we are printing the content of the variable. Let us take the format specifier %d, for example. This prints a number, so a number must be provided for printing. This is done by adding another argument to the printf statement as shown here. Init age is 25, print I am %year-old, backslash n, age. In this example, printf has two arguments. The first is a string, I am %d years old. backslash n, then the second is an integer age. The argument list. When printf processes its argument, it starts printing the character it finds in the first argument one by one. When it finds a person, it knows it as a format specification. It goes to the next argument and uses its value and printing it according to that format specification. It then returns to printing character at a time from the first argument. It is okay to include more than one format specification in the printf string. In that case, the first format specification goes with the first additional argument, second goes with second, and so forth. Here is an example. Init x is equal to 5, y is equal to 10, printf x is %d and y is %d \n x comma y. Person. Every format specification starts with a percent sign and ends with a letter. The letters are chosen to have some mnemonic meaning. Here is a partial list. %C, print a single character. %D, print a decimal, paste and number. %E, print an exponential floating point number. %F, print a floating point number. %G, print a general format floating point number. %I, print an integer in base 10. %O, print a number in octal base 8. %S, print a string of characters. %U, print an unsigned decimal base 10 number. %X, print a number in hexadecimal base 16. %, print a percent sign. Backslash % also works. To print a number in the simple way, the format specifier is %D. Here are some example cases and results. Printf produces %D, 0, %D -7 %D 1560133 635 150 133 %D -23 203 506 5302 -203 506 5302. You notice that in the simple %D way, there is no predetermined size of the result. Printf simply takes as much space as it needs. The width option, as mentioned above, simply printing number was not enough. There were special options that were decided. The most important was probably the width option. By saying %5d, the number was guaranteed to take up to 5 spaces, more if never less. This was very useful in printing tables because small and large numbers both took the same amount of space. Nearly all printing was monospace in those days, which means that a W and an I both took the same amount of space. This is still common in text editors used by programmers. To print a number with a certain minimum width, say 5 spaces wide, the format specified is %5d. Here are some sample cases and results. We will use the symbol to explicitly indicate a space. Print produces %5d 0 0, %5d -5 -7, %5d 1560133 635 1560133 635, %5d -23 506 5302 -23 203 506 5302. Notice that for shorter numbers, the result is padded out with leading spaces. For excessively long number, there is no padding and the full number is printed. In normal usage, one would make the field width enough for the biggest number one would ever expect. If your numbers are usually 1, 2, or 3 digits long, then %3d is probably adequate. In abnormal cases, one could end up printing a number that is too big for the field. Printf makes the decision to print such numbers fully, even though they take too much space. This is because it is better to print the right answer and look ugly than to print the wrong answer and look pretty. Filling the extra space meant printing a small number like 27 in a %5d field. The question then became where to put the 27 and what to put in the other 3 slots. It could be printed in the first 2 spaces, the last 2 spaces, or maybe the middle 2 spaces that cannot be determined. Can be determined. The empty spaces could be filled with the blank character or perhaps stars star 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 27 or 27 star 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 or star star 27 star or dollar sign dollar 27 or equal sign equal 27 or leading zeros like 00027. These extra characters are often called check protection characters because they are intended to prevent bad guys from changing the dollar amount on a printed check. It is relatively easy to change a space into something else. It is order to change a star, dollar sign, or an equal sign. Printf provides space fill left or right and zero. Fill left only. If you want check protection or centering, you need to make other arrangements. But even without check protection or centering, Printf still has an impressive and bewildering collection of options. The justify option using the printf numbers can be left justified printed in the left side of the field or right justified printed in the right side of the field. The most natural way to print the numbers seem to be right justified with leading spaces. That is what %5d means. But print a base 10 number in the field of with 5 with the number right aligned and front filled with spaces. To make the number left aligned, a minus sign is added to the format specifier. To print a number 5 spaces wide and left justified left aligned, the format specifier is %-5d. Here are some sample cases and the results. Printf produces %-5d, 0, -5d, %-5d, -7, %-5d, 1560, 133, 65, 1560, 133, 65, %-5d, -23, 203, 506, 53, not 2, -203, 506, 53, not 2. As before, for shorter numbers, result is padded out with spaces. For longer numbers, there is no padding and the number is not shortened. The zero fill option to make things line up nice and pretty. It is common to write a date using leading zeros. We can write May 5, 2003 in US as 05/05/2003. We could also write it as 2003.05/05. Notice that in both cases, the leading zeros do not change the meaning. They just make it line up nicely in list. When a number is zero filled, the zeros always go in front, and the rest of the number is both left and right justified. In this case, the minus sign has no effect. To print a zero filled number 5 spaces wide, the format is the %-05d. Here are some example cases of the results. Printf produces 05d, 0000, %-05d, -7, -0007, %-05d, 156, 133, 165, 156, 133, 65, %-5d, -203, 506, 5302, -203, 506, 5302. Shorter numbers are padded out with leading zeros, longer numbers are unchanged. Fun with plus signs. Negative numbers always print with minus sign. Positive numbers and zeros usually do not print with a sign, but you can request one. A plus in the format specifier makes the that requires to print a sign number 5 spaces wide. The format specifier is %+5d. Here are some sample cases and results. Print produces %5d 0 plus 0, %5d -7, %5d 1560133 635 plus 1560133 65 %5d plus 5d -203 506 5302 -203 506 5302. Notice that 0 is treated as a positive number. Shorter numbers are padded, longer numbers are unchanged. Plus and minus are not related. Both can appear in a format specifier. The invisible plus sign. This one is a little bizarre. It is an invisible plus sign. Instead of printing a plus on a positive number and 0, we print a space where the sign would go. This can be useful in printing left justified numbers where you want the sign minus signs to really stand out. Notice these two alternatives. Printf %+-5d, 0 plus 0, percentage plus minus 5D minus 7, percentage plus minus 5D 1560133 5635 plus 1560133 635, percentage plus minus 5D minus 203506 5302 minus 203506 5302, printf minus 5D 00, print percentage minus 5D minus 7 percentage minus 5D 1560133 635 1560133 635 percentage minus 5D minus 203506 5302 minus 203506 5302. Remember from above that the format specifier percentage 5D we get the following results shown again for easier comparison. Printf produces percentage minus 5D 00 percentage minus 5D minus 7 percentage minus 5D 156013635 156013365 percentage minus 5D minus 203506532 minus 203506532. Notice that the plus sign disappear, but the sign still takes up the space the format of the number. Notice also that we can combine several options in the same format specifier. In this case, we have combined the option plus minus and pi, or space minus and pi, or just minus and pi. Plus space and 0. Here is another example of combining several options at the same time using the format specifier percentage 0 5D or percentage 0 space 5D. We get the following results. Percentage space 0 5D 0000, percentage space 0000, or minus 7, it is minus 0007, for 1560133 635, space 1560133 635, for minus 203 506 5302 minus 203 506 5302. Using the format specifier percentage plus 0 5D or percentage 0 plus 5D, we get the following results. Percentage plus 0 5D 0 plus 0000 minus 0007 plus 1561335 635 minus 203 506 5302. When we combine plus and space at the same time, the space arranged for a room for a sign and the plus uses it. It is the same as if the space was not even specified. Plus takes priority over the space. Summary: the options are also called flags, and among themselves they can appear in any order. Here is a partial list: flag, effect, none, print normally, right justify space fill, minus left justify 0, leading 0 fill, plus plus print plus on positive numbers, invisible plus sign. After the options, if any minimum field width can be specified. Print says the percentage yes option allows us to print a string inside a string. Here is an example: a character percentage grade. If year equal to 11, grade is equal to junior, plus percentage s is a percentage s percent front grade. The left justify flag applies to strings, but of course the 0 fill plus sign and initial plus sign are meaningless. Printf produces percentage 5s double quote blank percentage 5s a within double quotes a percentage 5s within double quotes ab percentage 5s within double quotes ab c d e f g ab c d e f g. Printf produces percentage minus 5s double quote blank percentage minus 5x within double quote a percentage minus 5s within double quotes ab percentage minus 5s within double quotes ab c d e f g is as ab c d e f g. Floating point numbers are those like 3.1415 that have a decimal point someplace inside. This is in contrast to ordinary integers like 27 that have no decimal point. All the same flags and rules apply for floating point. numbers as we do for integers, but we have a few new options. The most important is a way to specify how many digits appear after the decimal point. This number is called the precision of the number. For ordinary commerce, prices are often mentioned as gold dollars or as dollar cents, and zeros are 2 digits of precision. For gasoline prices are mentioned as dollars, cents, and tenths of cents, 3 digits of precision. Here are some examples of how to print these kinds of numbers. Let E is equal to 2.718281828. Printf produces percentage dot 0f E3 percentage dot 0f dot E3 dot percentage 0.1f E 2.7 percentage 0.2f E 2.72 percentage 0.6f E 2.798 to 82 percentage FE 2.798 to 82 percentage 0.7f E 2.798 to 818. Notice that if a dot and a number are specified, the number in the dot as many places should be shown after the decimal point. Notice that if no dot and precision are specified for percentage f, default is percentage 0.6 f, 6 digits after the decimal point. Notice that if a precision is 0 is specified, the decimal point also disappears. If you want it back, you must list it separately after the percentage format specifier. We can specify both the width and the precision at the same time. Notice especially that 5:2 means a total width of 5 with 2 digits after the decimal. It is very common natural to think it means 5 digits in front of the decimal and 2 digits after, but that is not correct. Be careful. Percentage 5.0 E3 percentage 5.0 F dot E3.0 percentage 5.1 F 2.7 percentage 5.2 F E 2.7 percentage 5.7 F E 2.718 to 818. We can also combine precision with the flags we learned before to specify left justification, leading zeros, plus signs, etc. Printf percentage 5.1 F E 2.7 percentage minus 5.1 F E 2.7 percentage plus 5.1 F plus 2.17 plus or minus 5.1 F plus 2.7 percentage 5.1 F E 002.7 percentage plus 05.1 F E plus 02.7 percentage 05.1 F E 02.7 percentage minus 5.1 F E 2.7. Designing the perfect spec. If you are designing a Printf format specifier, the first step is to decide what kind of a thing you're printing. If it is an integer, a float, a string, or a character, you will make different choices about which basic format to use. The second big question is how to wide your field should be. Usually this will be the size of the biggest number you ever expect to print under normal circumstances. Sometimes this is controlled by the amount of space that is provided on the pre-printed form, such as a check or an invoice. Decide what you would like to print under the variety of circumstances. In this paper, we have often illustrated the results by using a small positive number, a small negative number, an oversized positive number, and the oversized negative number. You should include this option as well as large but not oversized numbers. Design your format for biggest number that you would normally expect to see. Summary needs for the test. The Printf test includes a variety of matching problems. They are designed to be tricky, and students' feedback indicates that if everything that they are more tricky than expected, you can use the process of elimination to make this test very fast and accurate. As you look at a common feature in the answer line, you can rule out all those Printf statements that do not have that feature. Very quickly, you can narrow your options to 1 or 2. Easy features, it is easy to see if the short numbers have very leading zeros? If so, there must be a zero in the formatting specification. It's easy to see if the positive numbers have plus signs. If so, there must be a plus in the formatting specification. Before, between, and behind. Next thing to watch for is the before, between, and behind of numbers that is printed in a formatting specification like x percentage phi dz. There is an x before the number and an z behind the number. The x and z are not part of the forward specification, but they are part of the printed result. Everything else that prints is between. To decide whether there is anything before or behind a number, look at the oversized negative number. Any spaces before it are surely before the format specification. Any spaces behind it are surely behind the format specification. Here is an example. If minus 205065302 prints as minus 205065302, you can be sure that printf string is percentage ... with no spaces before the formatting specification and one space behind. That is because all the print positions begin the percentage and whatever goes with it are used up by the oversized number. Once you have determined what is before and behind, you can use that information to match against matching choices. Often this will give you the answer directly. The invisible plus sign, compare the oversized negative number to the oversized positive number. If the positive number has an extra space in front, it is an invisible plus sign. If there is no extra space, there is no invisible plus sign. Left justification, subtract before and behind. Look at what is left. Look at the small negative number. Where are the extra spaces printed? If they are in front, the number is right justified. If they are in back, the number is left justified. If they are in front and in back, you did something wrong. Conclusion, the printf function is a powerful device for printing numbers and other things stored in variables. With this power, there is a certain amount of complexity. Taken all at once, the complexity makes printf seem almost impossible to understand, but the complexity can be easily unfolded into simple features, including with precision, signage, justification, and fill. By recognizing and understanding these features, printf will become a useful and friendly servant in your printing endeavors. Thank you.